November 7th, 1943, Carpic Airfield KH, France. The brutal headwinds over the English Channel had consumed fuel at an alarming rate, and Second Lieutenant William E. Roach of the 358th Fighter Squadron, 355th Fighter Group, watched the gauges of his Pratt Whitney R-2800 engine drop toward empty, each tick a reminder that he faced an impossible choice: press on toward the tantalizing safety of England, or gamble on the patchwork of French fields below, most occupied by German forces. One airfield looked almost friendly, familiar enough to risk it, and with careful precision, Roach guided his massive Republic P-47D Thunderbolt, serial number 4222490, nicknamed Beetle, to a smooth grass landing, following a ground vehicle to the parking area and shutting down his engine only to realize that the Germans he had been fighting mere minutes before now surrounded him with rifles drawn, and in that instant his war as a combat pilot ended, destined instead for Stalag Luft I, while the Germans began an unintended education in American industrial might. What they discovered when examining Beetle fundamentally altered their understanding of American engineering philosophy and material abundance, revealing that the P-47 was not just a fighter, but a manifestation of production capability, technological sophistication, and strategic foresight. And over the next 18 months, as German engineers disassembled, tested, and even flew captured Thunderbolts, they confronted an uncomfortable truth. Germany had not fallen behind in aviation technology. It had been competing in an entirely different category of industrial warfare. German combat reports from spring and summer 1943 had reflected a mixture of contempt and confusion. Experienced Luftwaffe pilots accustomed to the nimble FW-190 and Bf-110-9 found the American fighter absurdly large, ponderous at low altitudes, sluggish in turns, seemingly blind to conventional dogfighting requirements. Yet hints in these reports revealed something more troubling. The Thunderbolt, once it chose to disengage, could not be caught in a dive. Its 8 heavy machine guns unleashed devastating firepower. Its armor resisted standard 7.92mm rounds and sometimes 20mm cannon fire. And even badly damaged planes limped back to England intact enough to astonish German engineers. When Beetle rolled to a stop at Carpic, German personnel recognized the intelligence value immediately, surrounding the aircraft with armed guards, painting over American markings with Balkenkreuz, and applying RLM-04 yellow on undersurfaces to prevent friendly fire, before transferring it to Rechlin, the Luftwaffe's premier testing facility northwest of Berlin, where Hans Werner Lerche, chief engineer and principal test pilot, approached the Thunderbolt with professional curiosity, documenting the cockpit's bewildering complexity, twice the gauges of German planes, unfamiliar levers, and the turbo-supercharger system that required theoretical knowledge, all managed automatically in a system that German fighters controlled manually. Lerche's meticulous ground studies revealed the sophisticated engine start sequence of the 18-cylinder R-2800 double wasp, the roar of which differed from any German radial or inline engine. And as he taxied the aircraft, feeling nearly 13,500 pounds under him, he noted the weight advantage compared to a fully loaded FW-190. Yet once airborne above 20,000 feet, the Thunderbolt transformed. The turbo-supercharger maintained full power while German engines gasped for oxygen. The P-47 accelerated in dives past 500 miles per hour, rolling faster than any German fighter he had flown. And Lerche, testing systematically, documented the P-47's superiority at high altitudes, an insight that would trouble Luftwaffe headquarters, who still believed German designs were supreme. Over weeks, every system, dimension, and component was scrutinized. The R-2800's forged aluminum pistons, sodium-cooled valves, high-grade steel crankshaft, and precision manufacturing amazed metallurgists who understood but could not replicate. While the turbo-supercharger system, complete with intercooler and automatic regulators, exposed engineering sophistication Germany could not mass-produce due to material shortages and Allied bombing. The Thunderbolt's armament, 8.50 caliber Browning M2s, 3,400 rounds, electrically heated gun bays, fired flawlessly under testing. While armor plating around the cockpit, oil coolers, and turbo-supercharger revealed American willingness to trade weight for pilot survivability, a stark contrast to German design philosophy. Maintenance accessibility, integrated radios, SCR-274N and SCR-515A systems, and the IFF, Identification Friend or Foe, demonstrated operational foresight and technological superiority, revealing the cumulative impact of American industrial abundance, a fighter aircraft built exactly to design specification with no material compromise, produced in quantities Germany could never match. Subsequent captures, such as Lieutenant Lloyd H. Hathcock's P-47D 4275971 in May 1944, reinforced these lessons, providing tactical recommendations to German pilots. Engage below 15,000 feet where the Thunderbolt was less effective, avoid chasing dives, and focus concentrated fire on damaged planes. But even these insights could not overcome the fundamental strategic problem. Germany faced an opponent with virtually limitless material resources, replacing lost aircraft within days, training pilots in abundance, and applying industrial capacity that rendered tactical skill increasingly irrelevant. As German engineers meticulously tested captured P-47 Thunderbolts at Rechlin and other Luftwaffe facilities, the stark reality of the industrial gap became undeniable. While every measurement, engine test, and weapons trial confirmed the technical competence of German designs, it also highlighted a sobering truth. No amount of tactical brilliance or pilot skill could overcome the sheer scale of American production. The P-47, rugged, heavily armored, and equipped with 8.50 caliber Browning machine guns, turbo-supercharged for high-altitude dominance, embodied an industrial philosophy Germany could not replicate. A balance of adequate engineering, relentless material abundance, and disciplined tactical doctrine. German pilots noted that at altitudes above 25,000 feet, the Thunderbolt maintained combat effectiveness, while their own FW-190s and BF-109s struggled, engines choking in thin air, forcing Luftwaffe interceptors into defensive maneuvers or fruitless dives. Captured aircraft provided more than numbers on a page. They offered tangible, physical evidence that the Allies were not only better supplied, but strategically smarter, integrating production, logistics, and training into a seamless system that allowed quantity to amplify quality. Performance comparisons were chilling. The P-47D could reach 426 miles per hour at 30,000 feet, with a service ceiling of 42,000 feet, while German fighters rarely exceeded 35,000, and those that did were underpowered and vulnerable. Range tests further exposed limitations. With drop tanks, Thunderbolts could escort bombers deep into the Reich, while German fighters remained tied to short-range defensive missions. Examination of gun camera footage and combat damage patterns revealed disciplined American tactics, high-altitude dive and zoom attacks, and mutual support formations, maximizing P-47 strengths while minimizing vulnerabilities. A stark contrast to the German reliance on individual skill and aggressive dogfighting. Beyond technical insights, the psychological impact was profound. Luftwaffe pilots realized that American industrial might, not just aircraft quality, dictated the air war's outcome. By 1944, American production outpaced Germany 5-1, delivering not only fighters, but bombers, transports, and support aircraft, all supported by superior logistics and pilot replacement programs. Even elite German aces, who once prided themselves on aerial mastery, found themselves confronting overwhelming numbers of capable aircraft, where each engagement was dictated less by skill than by attrition and material advantage. The captured P-47s, nicknamed the Jug or Indiana by German pilots, became symbols of this relentless, systemic dominance. Aircraft that German engineers could dissect, pilots could fly, yet nothing could reverse the strategic calculus they represented. By war's end, the meticulous evaluations, technical reports, and first-hand observations documented a fundamental truth. Industrial capacity, applied consistently with competent engineering and supported by disciplined tactics, was the decisive factor in modern air warfare. And the Thunderbolt, powerful, versatile, and mass-produced, stood as the clearest, most tangible proof that even superior design and pilot skill could not overcome the unstoppable momentum of overwhelming resources. Captured aircraft like William Roach's Beetle or Lloyd Hathcock's P-47s had taught Germany lessons it could measure but never act upon. And in the final months of the European conflict, as the Luftwaffe faced continuous bombardment and attrition, the lesson was unmistakable. In the industrial war of the 20th century, knowledge alone could not win. Scale, production, and logistical mastery did. Beyond engines, armor, and machine guns, the captured P-47s told a story about the men who flew them, the pilots whose skill intersected with industrial might, and the broader consequences of war dictated by resources rather than heroics alone. William Roach, stranded at Karpik Airfield and later interned at Stalag Luft 1, and Lloyd Hathcock, the lone African-American pilot navigating captivity and prejudice at Stalag Luft 3, embodied the human side of these machines, men whose fates intertwined with the very aircraft the German engineers studied with obsessive precision. As Roach watched his Beetle stripped, measured, and flown by Luftwaffe test pilots, he could hardly imagine that the aircraft's ultimate power lay not in its guns or radial engine, but in the massive American industrial ecosystem that produced thousands more like it, each a force multiplier far beyond any single pilot's capability. Meanwhile, German engineers and pilots, despite their exceptional technical skill and courage, faced a relentless reality. They could analyze every control, every lever, every turbocharger manifold, yet lacked the materials, factories, and workforce to replicate what American abundance had made routine. The tactical lessons were clear. Avoid combat above 20,000 feet. Attack P-47s aggressively at low altitude. Never underestimate their armor or firepower. Yet these recommendations could not reverse the strategic tide. Observers noted the disciplined formations, the dive and zoom attacks, the mutual support tactics, and the precise maintenance that kept Thunderbolts flying in vast numbers, a testament to systematic operational thinking and a stark contrast to the desperate improvisation of a resource-starved Luftwaffe. By 1944, the cumulative weight of American industrial, tactical, and logistical advantage became inescapable. Each day, German pilots confronted more capable aircraft, skillfully flown, backed by endless fuel, ammunition, and replacement planes. The captured Thunderbolts, physically present yet strategically untouchable, became almost symbolic. They represented a war Germany could observe with full understanding, but could not hope to win. Beyond technical data, the experience illustrated a deeper truth about modern warfare. Victory depended less on individual brilliance than on the capacity to translate knowledge into production at scale. The P-47, once just an American fighter in the sky, evolved into a lesson in systems thinking, resource allocation, and industrial strategy. Its story continued long after the war. Roach and Hathcock returned home, their aircraft gone, but the lessons it embodied immortal, influencing post-war Air Force development, aircraft design, and operational doctrine. The engineers who flew these captured Thunderbolts, like Hans Werner Lerche, survived, carrying their meticulous observations into peacetime aviation. Yet the ultimate irony remained. They had measured, understood, and recorded every advantage, limitation, and capability of America's industrial weaponry, only to confront the immutable reality that insight alone could not substitute for production, raw materials, and infrastructure. The P-47's legacy was therefore twofold: a triumph of American design, manufacturing, and operational doctrine, and a mirror held up to Germany, revealing how a nation's industrial system could decide the fate of a war, leaving bravery, skill, and tactical genius as insufficient tools when weighed against the inexorable scale of production and resource abundance. In the end, the captured Thunderbolts were more than machines. They were educators, proof of a strategic philosophy that elevated systematic preparation, redundancy, and scale above individual feats. A philosophy that defined the Allied air war over Europe and set a precedent for modern industrialized warfare that endures to this day. As the war progressed into 1944 and 1945, the captured P-47s at Rechlin and the demonstrations by Circus Rosarius became a tangible representation of the shifting balance of power in the skies over Europe, a testament to what happens when industrial capacity meets tactical application in overwhelming measure. German pilots who attended the evaluations, who climbed into the cockpits, fired the guns, and dove the aircraft through its paces, could not ignore the fundamental truth: no amount of skill or experience could fully compensate for the sheer quantity, reliability, and versatility of American aircraft. The lessons were stark. High-altitude superiority dictated engagements, disciplined formations multiplied effectiveness, and logistical mastery ensured that no losses were permanent. Every aircraft shot down, replaced by another from a production line that never slowed. Engineers meticulously documented every observation, every measurement, every flight characteristic, yet they were acutely aware that their knowledge could not be turned into action. Their factories lacked the aluminum, steel, precision machinery, and skilled labor to replicate what they had witnessed. The psychological impact on Luftwaffe morale was profound. Each demonstration, each captured aircraft reinforced the sense that the Allies' industrial dominance was an unstoppable force, and that combat success alone could not reverse a strategic disadvantage imposed by production and resources. For the American pilots, their aircraft remained instruments of survival and triumph, each P-47 embodying not just engineering excellence, but the collective might of a nation mobilized for total war. The captured Thunderbolts, sitting with their hastily applied Vulcan crosses, told the German engineers a story of abundance, planning, and foresight, a story that they could read with perfect clarity, yet whose ending they could not change. The irony was profound. The Germans had the data, the knowledge, the pilots to understand what made the P-47 so effective. Yet that understanding highlighted the insurmountable gap between insight and capacity, between knowing and producing, between admiration and competition. By the spring of 1945, as Allied forces swept into Germany, the P-47s captured at Rechlin and other sites stood as monuments to American industrial ingenuity.
their presence a silent but undeniable proof that the fate of the war had already been decided by the relentless application of resources, production, and systemic planning long before the last aerial dogfight had ended. And as these aircraft were recovered by American forces, their lessons were preserved in intelligence reports and post-war evaluations, ensuring that the story of the Thunderbolt, its capabilities, and the strategic insight gained from its capture would inform not just immediate military planning, but the future of air power for generations.
By the end of the war, the captured P-47s had fulfilled their unintended role as teachers, revealing the profound truth that industrial might, when combined with disciplined tactics and effective logistics, could decisively outweigh technical ingenuity alone. William Roach's Beetle, Lloyd Hathcock's P-47, and the other Thunderbolts examined at Rechlin became silent witnesses to a conflict where production numbers, resource abundance, and the ability to sustain losses dictated victory more than individual heroism or aircraft maneuverability. And the pilots themselves, whether held as prisoners or returning to the skies, carried with them stories of resilience and endurance, of enduring months behind barbed wire while their planes were dissected and studied. Each measurement and flight test a reminder of the vast machinery of war that operated far beyond the cockpit. Roach would emerge from Stalag Luft I liberated by the Soviets, his memories of forced confinement and the betrayal of landing in enemy territory tempered by the knowledge that his aircraft had unwittingly contributed to an education that, while too late to save Germany, reshaped the understanding of aerial combat. And Hathcock, enduring 11 months as the only African-American pilot among thousands of white prisoners, survived brutal marches and camp relocations to witness liberation, later pioneering reconnaissance innovations and contributing to the desegregation of the U.S. Air Force, a testament to human perseverance alongside industrial triumph. German test pilot Hans Werner Lerche, having flown over 125 aircraft types without a single crash, returned home carrying the knowledge of how the Thunderbolt's 18-cylinder Pratt Whitney R-2800 engine, turbo-supercharger, heavy armor, 8.5 caliber guns, and disciplined operational doctrine combined to create an aircraft whose effectiveness was inseparable from the industrial system that produced it. Yet he, like his fellow engineers, could do nothing to replicate it, an observer of capability without the means to recreate it, illustrating the inescapable strategic lesson of the P-47, that a nation's ability to conceive, produce, and sustain modern weapon systems at scale with abundant resources and systematic support ultimately determines the outcome of war. And so the story of the Thunderbolt, its captured examples, and the pilots who flew them stands as both a narrative of technical marvel and a broader parable of industrialized warfare, showing that while courage, skill, and ingenuity shape battles, it is the relentless machinery of production, logistics, and material superiority that shapes history, leaving the Germans to document meticulously what they could not match, the Americans to wield the skies with overwhelming force, and historians to marvel at how a single aircraft, dissected in enemy hands, could so clearly illuminate the decisive power of industrial capacity in the Second World War. A lesson whose resonance echoes through every era of military planning and every story of conflict waged not just in the air, but across factories, railways, and assembly lines, where victory is forged long before the first shot is fired.